Welcome to the repair log for this monster digital clock. This measures in at 10 by 22 inches and was largely found in industrial and office applications, as well as could be found in a hobby magazine for the do-it-yourselfer to build as a kit. Stick around, stay tuned, we're going to get into this beaut. Yeah, so this was found on eBay for parts are not working. That's the way I like them. Usually you can get into them and find something simple and get them up and running. This one was not the case. A little quick, this is a Caringella Electronics. It appears to be a self-etched arrangement. A lot of these were published in magazines back in the 70s, and you could take the foil patterns and make your own circuit boards, etch them yourself. And with the rough cut and some of the other things I'm seeing, I don't think they would have turned out a rough product like this right from Caringella Electronics. So my thinking is somebody made this themselves, and they actually did okay. So as rare as this clock is, I wanted an original one. This came in a homemade cabinet. I'm just happy I have it. So we'll go over a little bit of what I found. I thought it was going to be easy to get this up and running, and it was doing all kinds of wacky things with the display. Turns out there were several things wrong with it. This thing apparently never worked. With all that I found wrong with it, I don't think the original builder had any luck with getting this up and running. There were 15 bad LEDs in the display board. The display cables between the driving circuit and the display board, some of those were cross-wired, so that was another major issue. We have 7 transistors for segment control. This is a multiplex display, so the ones in the metal cans there, they were installed incorrectly. 2 of the legs of the transistor, each transistor, were reversed, so they had to be removed, legs bent, and reinstalled. I can't remember if it was the base and collector messed up or what have you, but anyway, they were in incorrectly, as well as a transistor up here, which in this circuit controls interdigit display blanking using the output enable pin of the 5314. So that was yet another problem. There's a diode over here missing, which goes along with these guys, and that controls the base of the each digit driver transistor here. There's 6 of those, so there'd be 6 diodes to control each base independently. One digit was not working because there was a missing diode. Interesting. There was no provision for setting the time, i.e. set switches. They were never wired on the board. So I had to trace the circuit. The holes were drilled. Traces were on the board. It just had to be soldered in. So I don't get what that was all about. So pretty interesting. I think that covers about everything I found wrong with it. Once I found all that stuff and changed a bunch of LEDs in the display board, it was up and running. And from there, I'll take you the journey of replacing LEDs in a display board. So here we are replacing LEDs. As this thing was found, I don't know what was in here for LEDs. There were some in backwards, some were bad. to get this clock up and running, I threw a bunch of miscellaneous LEDs in it just to see what I could do. And the inconsistencies in the display drive me nuts, so a lot of them are pretty dim, so who knows what was in here. But here we have the ones of hours position. Much better. All those replaced. Now I just have to do the rest of these. It's a lot of work. I'm using King Brights. And a bag of 200. So all from the same lot, so I'll change them all. So it seems to help. This 45-year-old solder, a little oxidized on the outside. Just remelting it, a little fresh solder before using the suction tool. I use a plunger. And just remelting this beforehand seems to make sucking the solder out a little easier. Some of these I already changed these LEDs just to get it up and running, so I'm not going to remelt those, but these, you can see it's a little more oxidized. That's the stuff I'm hitting. And then I'll come through with a plunger and just suck all the solder, and the LEDs more or less fall out. A lot of them seem to have bent legs on them, so you just gotta straighten the legs out. And I have this soldering iron on a variac just to cut the temperature back a little bit. These copper traces seem to be a little fragile. That's fragile. So I'm trying to keep the dwell time down on it, temperature down on it. Did I do these? I think I did these already. A little solder wick to finish some of these up that don't quite suck all the way out. The single-sided boards really are easy to work on. I would love a Hayco unit right now. 27 LEDs per digit. Do a rough brush, little cotton swab, clean it up a little bit, and then I'll go over with a cotton swab again to get the rest of the residue off. Flat side, short leg, cathode. In this case, faces down. Little painter's tape. So there's paint on it. I think it's losing its stickiness. It's just enough so you can hold it and turn it over. Once it's turned over, and you just go in, do one side of each LED. Okay, so yes, a lot of them are crooked. Solder one side of each one. Then you come back. And you just quickly reheat one hand, finger with the other one, push it to the board. You can use the legs to kind of eye them up a little bit. And get them close. And you might have to go back and touch them up again. Keeping dwell time down. Don't strain the LED while it's cooling. Test. Yay. It works, it works. That one only counts to 5. Alright, so everything's working. And then the last one I have to do is this one. This is 12-hour clock. I could cheat and just do these, but this clock chip will do 24-hour time, so I will change them all in case the next individual wants to make 24-hour clock. I'm going to even put the switch to activate that in the back as an option. Well, display board is looking better. Uniform illumination, all the digits. Been running for a couple days. Of course, we got another issue. It runs fast. Okay, so our oscillator is represented here in the schematic. Here's a couple NOR gates in the 4001. They have a test jack. The way they build this clock, we actually have that output. I was able to connect a frequency counter to that, and we're supposed to be 491,520. The lowest I can get it is 491,605, but we need to get it slowed down a little bit. The output of that oscillator gets fed up to the 4020 here, clock in, and there's your 2 to the 13th output, dividing down to your 60 Hertz, which then gets fed to the 5314. So after much playing with capacitance and a trimmer and a low capacitor, I guess is what you call them. I'm new to oscillators, by the way. I pretty much could not tune down to 491.520 kilohertz without getting it to stop oscillate, and upon further talking with people, that has probably drifted beyond its stated value. So, change of plan. So we just had to disable the oscillator that was currently in the clock, or originally, and the 4001, 4020, remove those, put them away for safekeeping, and we have to get the clock controller a new 60 Hertz reference. So we use that, taking that from the line. So here's our 9 volt AC coming in from our wall transformer, and through a 100K resistor from this point here to rectifier, 100K resistor to pin 16, and across pin 16 to pin 12 is a 1N914 that gives you your 60 pulses per minute. That's your reference now. All this goes away. The downside is we can't have battery backup anymore. Okay, so clock keeps time. Yay! Be sure to check out the link that'll bring you to the radio electronics articles over 3 months or so that feature this clock. Good stuff. Thanks for watching. Hope you enjoyed the video. Welcome to the repair log for this. Oh my gosh.